Okay, the first topic of the semester, the first topic for calculus is called limits. But before we start, do you have an idea, in general, what is a limit? In your own words, what's a limit? Huh?
Where you can cross.
Okay, yeah, that's one. Anyone else?
An end.
An ending, yeah.
Something that stops you from doing something.
Okay, very good. No, it's okay. It's okay, very good. In general, we have definitions for limits. But here in mathematics, the definition is a little different. Here in mathematics, a limit is going to be an operation. It's going to be an operation that is going to allow you to approach a value. Okay? What is that? For example, imagine that you're a person here, a guy walking on a certain highway or something. Forget me about my drawings, but not that. Okay? Let's say that then in this case there's a hole in here. Okay? And you don't want to fall in that hole. In mathematics, the limit is going to be the operation, the process that is going to allow you to get as close as possible to that hole without falling in that hole. Okay? Basic. So a limit is going to be the process, the operation that gets you to approach that hole or that point or that whatever without getting to that exact point. Okay? That is a limit here in calculus. Okay? Do you get the idea?
Yes.
Okay. As a definition, then a limit is an operation that allows you to approach to a bound. Okay, the key word here is approach. Approaching to. You're going to get very close to that value, to that hole in that case, without getting to that hole. And the notation for this is like this. We want to write the word limit as in limit. The function that you have, f of x, it could be any function, x squared, x to the cube, a trigonometric, an exponential, whatever function it is. We're going to call it f of x right now. And then here you're going to put the value that you're going to approach to in the x-axis. Okay? And that is going to be equal to a certain value here. Okay? That's the definition, that's the notation. We're going to do examples with numbers, but right now, this is going to be the definition. This is the way that we're going to write the limits. Okay? How do you read this? As this. The limit of f of x as x approaches c. Okay? That's the way to write it. The idea is that we're going to work with limits the entire portion. The entire first portion is going to be about this, about the limits. Today we're going to see the basic approach to limits, the easiest part, the graphical limits. Okay? So, how do we represent this using graphs of functions? In some cases, with asymptotes. But for example, let's say that I have a function, any kind of function. But to make it easier for you, I'm going to use a linear function. Example, let's say that is this line. This is going to be called f of x. Okay? Now, in this function, let's say that I'm going to take a value x here on the x-axis, any value. We're going to call that value c. Or A, or B, or C, whatever. It's just a number. Now, if I project that value here on my function, and then I get the value on the y-axis, what is this called? What is the value here that I want to put? If this is C and this is the function f of x, here what do I have? No. L if I use the limit, but normally, like you saw in Math 2 and Math 1, if you have a function C, you evaluate that C on the function. No. Why is the x-axis?
A, B, C, D?
No. It's going to be called f of C. Do you understand why or not? The image. It's called the image. It's called the image of C. Do you get that or no?
Yes.
No.
No?
The mirror of C.
Basically, the mirror of C. So, imagine this. You have the value of x, which is in this case is C. You put this inside this function, so instead of the x. So my answer is going to be f of C. That is if I evaluate this. But what about the limit? If I want to say, or if I want to represent the limit, for example, I want to express this, the limit of that function as x approaches C, what this means is that I'm not going to evaluate. What I'm going to do is approaching that value. What do I mean by approaching? That instead of taking that exact value, I'm going to approach to it. In what way? Well, for example, this means that I'm going to get or take values as close as possible to C. And if that happens, then I need to see what happens in my function. In what way? If I get close to C, then my function is getting close to a value, which in this case is exactly the same, but I'm approaching to that value instead of taking that value. Okay? So the limit means that if I approach this value, then I approach that value, which in this particular case is going to be f of C. That's the way to represent it. Do you understand that? Not so much. Okay, don't worry. We're going to do more examples. But that's the idea. The idea is that I'm going to approach a value C, and my answer is going to be the value of the graph that is approaching to. Okay? Seems confusing, perhaps. But we'll see. This is going to be my definition. Let's do an example with numbers. Okay, so it will be easier to understand. Okay. Let's say 3 and this is 4. Okay. Imagine this. In this case, for example, we have a graph, like a parabola or something. But here, in this case, what do I have? What is this? A hole. This is a hole, right? So, in this case, a hole is an empty dot. If I were to ask you, like you did in Math 2 or Math 3, how much will be for that function f of 3? What would you say? What would be the answer? No, because in this case, no, because in this case you have a hole. Unlike this one doesn't have a hole, so no problem with that. But in this case, for example, there's a hole. So when I say for this function f of 3, the answer is it doesn't exist. Going to do that. Do you understand that or not?
Yeah.
Yeah, sure?
So,
No?
when you put a hole in the exam, it doesn't exist.
Exactly. In this case, it doesn't exist because there's no hole.
Okay.
But in this case, for example, even you have the 4, yes, I know that, but you have a hole in there. So that hole means that there is no graph in there. So if I say for that function f of 3, even though you have the 4, there is a hole in there. So there's no graph.
And what if it's like 2? If of 2 will be an answer,
Then that will be
right?
something different, because there will be other values. Or for this specific value,
It's because it's exactly
there's a hole.
in the hole.
Exactly. Do you get that?
Yes.
Okay, now, what about the limit? For example, if I say, okay, same function, the limit of that function, but now I say x approaching 3. Do I have an answer now? What do you think?
Yes. Yes.
In this case, I have an answer. And the answer is going to be?
Function of
You already have the value.
or
In this case, it's 4. See the difference? More or less, okay.
Another one.
When I say yes, we'll go to the other one. When I have f of something, graphically speaking, it means that I need to see what happens at that exact point.
Okay.
In this particular case, there's a hole, doesn't exist. In this particular case, there is the graph, so there is a value. But with the limit, it's different. Because in this case, in the limit, instead of taking the exact value, you're looking for the value that you're approaching. In what way? Well, what this means is that you're going to approach as close as possible to the tree and see what happens to the graph. My graph is approaching what value? 4. Approaching the 4. Not taking the 4. Approaching the 4. Okay? That's what the limit means. Okay? Even if you have a hole in there, doesn't matter. You're approaching the hole. Yes? A little better now?
Yes.
Okay. Very good. Now, another example. What will happen if my function is something very different? Let's say that the graph is something like this. You have this, then like this. Let's say that this value is 4, this is 2 here, and all the way here is 4 or whatever. Let's say 5 to make it different than this. Okay. This function is very different. This one was a single curve with a hole, but now you have in this case 2 pieces. Okay. So let's see what happens. If I were to ask you what will be the limit for that function f of x as x approaches 4, what would you say?
2.
No. Because that can be.
5.
Also no.
pero es que
That's the problem.
you have to
No. In this case, for example, for this one, I approach that value from both sides, and then I approach the graph from both sides, and they get to the same point. But in this particular case, as I approach the 4, they get to 2 different values, but you cannot get 2 different answers. So, if they get to 2 different values at the same time, then we say that that limit in this case does not exist. No? Yes or no?
Yes.
You seem confused.
Yeah, but it's fine.
Sure?
And in the first one, it's also a hole. It will be a link, or
In which one?
in
Example 2.
the example 2. But that one, if it has a hole, it will be a link.
No, it still doesn't exist. Because the problem is that you cannot approach the same place. You're approaching different sides at the same time. So that cannot happen. Okay? So, let me repeat. In this case, as you approach the limit, remember, in this case it's from both sides at the same time. You look at the graph to see the answer. In this example, you approach the same value, which was 4. That's my answer. But in this example, at 4, you have different situations. So when you approach x upon x approaching 4 from both sides at the same time, the problem is that the graph gets to 2 different values. And that cannot happen. So you say that it doesn't exist. Okay?
or 2,5.
No, because the answer should be just a single value. Okay? So to avoid this, we need to do a little more analysis. So instead of just analyzing from both sides, we're going to find the limits, but from one side at a time. So for example, if I say this, the limit as x approaches 4, and then I put a little plus here in the 4. That will mean that I'm going to find the limit, but just taking from only one side, the right side. Okay, so in this case, this little plus here, this little plus means that you're approaching from the positive side, from the right side. From the right. What does that mean? Or what's my answer here? In this case, I'm not approaching from both sides. It's just from the right. Just from the right side. So I'm taking the right side of the graph. So now my graph is approaching 2.
Why 2, teacher?
Because you're approaching 4 from the right, but your graph is approaching what value in y? 2. If I were to say the limit x approaches, but now 4 from the left side, what would you say? 5. This little minus means from the left. Do you understand that? Yes.
Can there be like two going to the same side, or they always gonna be like on different sides?
For this, if you don't have a sign in this one, it's from both sides at the same time. That's why in this case it doesn't exist, because you get to different places.
And if they come from the same side?
That depends. For example, if this you need to put the little plus.
Profe, ¿puede apagar el aire, por favor?
So it's still on the line. So that's one. No?
Sí, bájale, súbale a la temperatura.
Any other question about this?
No.
Now, one last thing. From this example also, what would happen if instead of a limit, my question is, okay, give me the value of just f of 4. Just f of 4. What would be the answer now? 5. Very good. Why?
Because the other one is empty point.
Exactly. When I don't put the limit, when I just say f of something, I need to see what happens at that value exactly. I need to look for a full dot. So for example, when I say f of 4, the full dot is at 5. So that's my answer.
If there is no full dot, you will fill the gap?
No, you see that doesn't exist.
Oh, that's why it didn't exist.
Exactly. Exactly. Like in this case. But in this case, you have a full dot here of 5, so that's why the answer is 5. Yes?
And if you didn't have a hole in the...
No, either you have 2 holes or 1 hole and a full dot. You cannot have 2 full dots.
Okay.
Okay, it's always at least possible. Yeah, no.
Like the x is just to get in the exact position of something.
The f of x, this one? This one, that's the name of the function.
Okay, no.
That's the name of the function. That's part of the notation. Okay. Yeah.
No puedo. Se me caen las cosas.
When I have it. Exactly. Okay. When you evaluate the function, then you put the value of the x. And you put the limit on it because that is the value of x here. That's just the
Okay, now I got it. Yeah.
Okay? Fine.
Backup. Le dijiste no. Dice que es como cariño. Yo le hago.
¿Cómo va el video?
Sigue grabando.
No sé si te pregunta F de X, eso no es un límite, no sé si
Profe, ¿tenemos que copiar esa gráfica?
Okay. I don't know why, but for any reason the blackboard is not working. So what I did is just one example here. Okay, you can just copy it or on the video or there take a picture. What I want to do is something like this. It's something like activity. This is a big piecewise function. There are a lot of pieces. Rational, linear, etc. Okay? So the idea here is that, for example, I'm going to ask different limits for different values. You need to observe what value is the one that you're talking about to work with that. So, for this example, I'm going to call this example 3. Let's say, my first question is limit of the function is f of x, as x approaches -3 from the left side. Observe the graph. From the entire graph, if it says x approaches -3, that's the value of x that you're going to be observing. Where is it? Here. That's the value. So, if the question is the limit of that function as x approaches -3 from the left side, then check your graph. You're approaching -3 from the left side, so my graph is approaching what value of y?
0.
0. So the answer will be 0. Remember, you observe this, and the answer is the value of the graph in the y-axis. On the y-axis. If the question limit x approaches -3 but from the right side. Now it's from the right. Same value -3, but now it's from this side, from the right side. So also 0. Okay? And if I say the limit as x approaches -3 without direction, that is from both sides at the same time. No, it does. It does. Why? Because if you go from the left, get to 0. From the right, get to 0. From both sides, get to 0. And if I say f of -3, not limit, exactly -3, is there any value of full dot?
Yes.
Where? 0. Okay.
Why cannot be -3?
No, because that's the value of x. But the answers are in y.
So the answer is always at the y-axis?
In the y-axis, yeah. Let's do another one. No, I'm not going to raise it. Limit x approaches -2 from the left.
¿Qué sería la de abajo? La que va hacia abajo.
Ajá. Okay. Now the value of x is -2. It says the limit x approaches -2 but from the left side. Now you're approaching -2. My graph goes towards -infinity. Do you see that or no? Si no lo ven, díganlo. Que a algunos no les pasa problemas, que les dio -infinity.
¿Sí está bien?
¿Sí?
No, ¿puedo quitar otra vez?
Okay. Check the graph. If it were something like in 2 dimensions, you're working with x, but you're looking for y. Okay? You're approaching the -2, but your path, your highway, your graph, as you approach the -2, you're going down, 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 all the way to the
¿Y no hay un momento en el que llegue a -2?
No. No? Because to approach as close as possible to -2 without touching. Yeah.
Pero no, él no encuentra la otra que va para...
No, because you're getting to -2 from the left side.
Pero el menos 2 no tiene mucha gráfica.
Remember, you don't get to -2. You're only approaching -2. So, you're approaching -2 without touching the -2. But if you approach -2, my graph goes down, down, down. The graph. Yeah. Okay. If I say x approaches -2, but from the right side,
It's the same.
positive infinity. Why? You're approaching from the right side of -2, you're going towards infinity now. If I say the full limit, this is called full limit when it's from both sides. Approaching -2 from both sides, the answer will be? Doesn't exist. Why? Because it has different behaviors, different places. And if I say f of -2, doesn't exist. Why not? Because you have an asymptote. That's the reason. This one.
Okay, yeah, right.
The vertical asymptote. Okay so far? Another example, now with 0. Yeah.
So, it only exists if you can reach on either side or both.
And you get to a certain value of what that exists. And if it's full limit, when you get to that value.
So, why you can't get to the 1 point with both sides?
But what value? You need to look for the value. With which one? Minus 2?
Yes.
Now go with minus 2 here. Since you have an asymptote, the graph is not going to touch that asymptote.
Okay.
Never at all. That's why you cannot get to that value. Okay. With 0, it says limit x approaches 0 from the left, 0 from the right, the full limit, and f of 0. Try to observe on your own, please. Only if I say 0 from the left. 2? 2. Why? Because S0 is this one. But you're approaching from the left side. So my graph, as you approach the 0 in x, the graph is approaching what value in y? 2. 0, but from the right? 0, yeah. Because this is the 0 in x, but my graph is approaching in y? 0. X approaches 0 from both sides? Doesn't exist. You can tell that because those two are different. If those two are equal, like in the first case, this is the same. If they are different, doesn't exist. F of 0? Doesn't exist. Why? Because there is no full dot at all.
So when you can get all both sides, it doesn't exist.
That's the idea. This is going to exist if those two are the same. Like in this case, for example, left 0, right 0, full limit 0.
And if they exist, they are all gonna be the same always?
Those three at least. This is different.
Okay.
This could exist, but maybe this not. They are independent. Now, for example, with the 3. Limit x approaches 3. X approaches 3 from the right. F of 3. Okay, you can tell me that. Limit x approaches 3 from the left. What?
Minus 3.
Very good. Limit x approaches 3 from the right.
Minus 3.
Also minus 3.
The third one is also.
So, they are the same. You can see from the graph, this is also minus 3. F of 3?
Minus 3.
Minus 3.
If you have like limit f of x, like x to 3, is it gonna be always the same as?
As this?
Yeah.
No, they're independent. For example,
Uh-huh.
if you have instead of a full dot, an empty dot, a hole, those three will be the same, but this will be doesn't exist.
Okay.
Why minus 3?
Which one?
Like, never.
Check the value. Check the value of x. Then check the y. You approach that from the left, my graph is going 3. You approach from the right, my graph is going both sides, same value, and exactly at 3. Is there a full dot? Yes, here. That's also the value. Yeah.
And what if it says limit f of x until infinite?
Okay, we'll do that also. Limit x approaches infinity and limit x approaches negative infinity. Okay, this is a little different, but it's basically the same thing. Now, there is no exact value of x, it's infinity. What does that mean? That you're going to take a value of x towards infinity. That is, if I keep increasing the x towards the infinity, what happens to my graph? Approaches what?
1.
What? 1. Why?
Because there is an asymptote.
There's an asymptote. Very good. Why? Because if I keep increasing the value of x, there's still an asymptote, and the graph is going to get very close to that asymptote without crossing the asymptote. And that value of the asymptote in this case is 1. So the answer for this is 1. When you have x approaching negative infinity, in this particular example,
It's also 1.
it's also 1. Okay? But in some cases there will be different values. It depends on the asymptote. Okay? Questions so far?
No.
No? Sure?
Yeah. So why is it one?
Which one? Both?
Yeah.
Because of the asymptote. It's the behavior.
Because you go with asymptote and then click.
Exactly. Because in this case, for example, the asymptote is going to stay all the way to the infinity. So if I give values to x as close to infinity as possible, let's say 1 million, for example, the asymptote is the one that the graph is approaching.
Okay. So then we take the asymptote and then.
Exactly. Ustedes en el tercero vieron que se llama comportamiento final. Bueno, debieron haberlo visto. Comportamiento final de los gráficos. ¿No lo vieron?
¿O cómo se llama en inglés?
Behavior.
No, sí, pero no.
Bueno, debieron, pero no importa. Es que es eso. El behavior es este. Este es el behavior.
¿De la derecha?
¿Qué pasaría con todas de las
Depending on your value approaching to. Because in this case, you're approaching infinity, so you take the one that is going in that direction. You cannot have a so that's not so something perhaps it has something like this. You have an asymptote here and an asymptote there. If it's infinity, you take this one. The one that is infinity. If it's negative infinity, the one that is going down. Correct? But never like this.
In the left side? No, the right.
Zero from the left, and then 0. Because it's 0, x from the left, my graph goes towards the left. 1. Because that's what the 0 is. 0 in x. You take what is closest to 0 from the left. Okay. Okay, last one. Last one as we go. 6. On the left. On the right.
We missed 5. We just started teacher.
Yeah.
We missed 5.
Yeah, for now. For now. Because it's almost time. What's the 6? Okay, now with 6, and with that we finish. It says x approaches 6, but from the left. My graph is going towards infinity. 6 approaching from the right side. Also infinity. And in this case, from both sides, the two limits, also infinity. Okay? Again, remember. Since the limit is about approaching to, it's only when it's approaching to. But there is no set value. You cannot say 1 million or something. You don't know that. But you're approaching infinity. Last one, f of 6. There is an asymptote.
So it's almost like it's infinity, right? So
Good. An asymptote is imaginary. An asymptote is not the graph. An asymptote is like a boundary. There is no graph in there. Good. You see this? About these questions. You see, it's not that complicated to observe. Okay? So tomorrow we're going to continue with the activity here in class, the entire class. So bring activity, or you want to get ahead and do it, it's up to you, but we're going to dedicate the class. Okay? So if there are no questions, go for your cell phones and have a nice day.